Hello everyone. So this video is about using a breadboard and doing a breadboard simulation. Now that we've done a multi-sim simulation and we know what our circuit looks like, we want to implement this on a breadboard. However, if you look at my circuit right now, it's incomplete. I need to change it up a little before I can actually implement that in on my breadboard. Namely, this signal over here is going nowhere. Remember, probe is not actually part of my circuit. So I have this wire just sticking out, going nowhere. And I want to be able to see, if I have a signal or not. So I'm going to use an LED. So I'm going to go ahead and choose an LED, and I'm going to choose a blue. And of course, I can't just have LED by itself. I need to have a resistor. So I'm going to go ahead and grab myself a resistor. I'm going to change its value to 330 because that's what I usually use in class. So this should be very familiar by now. All right, so now I'm going to connect this up. The LED is going to connect to the signal, the resistor to the LED, and the resistor itself will go into the ground. So I'm going to run my simulation, and my president is voting yes, my treasurer is voting yes, so the signal should be yes. This should be 1, but my LED is dark. Now, why is that? Guys, if you remember, what are ones and zeros? They're voltage, and they're literally voltage values. So 1 is generally anywhere between 2.2 volts to 5 volts. And 0 is anywhere less than 1.2 volts. Now, we're not even talking about the region in between right now, which is a really weird region. We don't want to be there, right? But just the fact that our 1 can be anywhere from 2.2 to 5. Well, if you look at our blue LED, it wants about 3 volts. Well, chances are this particular 1 does not have 3 volts. Maybe it has 2.5, maybe it has 2.8, but that's just not enough to light up our LED. And I'm just changing colors a little bit so that it's easier to look at. So if I choose a different color LED, it should work. Okay, so I'm going to go ahead and replace my component. And I know that reds and greens and oranges don't eat as much voltage, so I'm just going to go ahead and choose red. And now I'm going to run the simulation. And it works exactly the way it's supposed to. So now we know how to get this thing working. So this is exactly what we're going to breadboard. So we have a more or less complete circuit here. And I'm saying more or less because it actually doesn't show how these particular chips are connected to power. But we do have the complete logical part of the circuit. And we're going to go ahead and breadboard that. All right. So let's take a look at our breadboard. Now you can get this breadboard if you go to a site called circuits.io, and you would have to sign up for a free account. When you do that, you'll need to go for New Electronics Lab. Now I already started this circuit, so I'm just going to go ahead and complete it. Now, guys, the site is pretty laggy when you start it, but once you start building the simulation, it's not so bad. So the very first thing I need is, of course, a battery. So we'll have to wait a little bit. So I'm going to click on components and I'm going to choose 3 AA battery pack. Now, why am I choosing this one? Well, that's because that's what I have in the class, in my class. I'm going to pull this down. Now take a look. If you move your mouse over, it tells you which one's positive, which one's negative. Also, one thing I really like about the simulator, when I move my mouse over, it highlights the entire rail that that particular slot is connected to. And if I'm moving over here, you can see that it's the entire horizontal rail. So I'm going to connect my positive, my VCC, if you will, in here, and I will keep that wire red. Right, remember, reserved colors for power. So far I have my VCC over here in this rail, in this horizontal rail, going lengthwise. And now I'm going to go ahead and route my VCC all the way down. Now, it might not make sense right now why I'm doing this, but by the time I will get towards the middle of this video, you will understand. So now I have VCC in this rail, this horizontal rail, and this bottom rail. So the next thing I'm going to do is I'm going to do exactly the same thing to my ground. It's my black. So it's in this rail adjacent to VCC, the horizontal rail, and I'm also going to go ahead and pull it down. And now I have my ground also routed around in this rail, this horizontal rail lengthwise, and this horizontal rail on the bottom going lengthwise. All right, so far I've done this part of my circuit, VCC and ground. So what's next? Well, I've got a bunch of switches over here, so I need to use those. So I need a 3-legged switch. Look, each of these switches actually have 1, 2, 3 legs, right? 2 inputs, 1 output, right? So let's go ahead and see if we can find a 3-legged switch. So I'm going to go ahead and scroll down and down some more. I wondered if I missed it. Oh, there we go. Slide switch. 3 legs, just like what we want. So I'm going to go ahead and put it over here. And Control-C and Control-V works just fine over here as well. So I'm just going to go ahead and copy that switch. A few other places. All right, when you look over here, you have terminal 1, terminal 2 on the other side, and in the middle you have COM. So when you look and consider your diagram over here, it kind of makes sense that this is the terminal 1, this is the terminal 2. Those are the options you're switching between. And this is the output, the COM port. So let's go ahead and wire that switch. So if you look at my switches over here, one leg goes to VCC, the other one goes to ground. So let's go ahead and do that. Now, it doesn't really matter if you wire terminal 1 to VCC and terminal 2 to ground, or you wire terminal 1 to ground and terminal 2 to VCC. They really are the same. It's just a switch. So let's go ahead and wire this one. And the last one. So this one's going to be VCC. And notice in this one, I'm actually doing terminal 2 going into VCC and terminal 1 going into ground. I'm just doing this. You don't have to do this way. Maybe you want to do it the other way. I'm just doing this to illustrate that there is no difference. And of course, if I move this anywhere along these columns, it's not going to affect my signal because my switch is still connected to the same rail. Okay, so far I've done my switches. So the next one would be to do my logic gates. So these are AND gates, and I would normally look for LS 74SO8. I don't actually have the 74SO8. I do have its CMOS brother in here, 74HC08. And it works exactly the same, and it even has exactly the same pinout. It really is the same except for being a CMOS. So when you look over here, I find here it is 74HC08, and it's also called quad AND gate. So I'm going to grab this lovely cockroach, and I'm going to place it right here. Now the next thing I would do is to look at the pinout. So when you look at the pinout for this cockroach, the very first thing you'll notice is this semicircle. If you had that chip in your hands right now, you would be looking for that semicircle to make sure you don't put in your chip backwards. But that is not an issue since we're using the virtual simulator. It puts it in the correct orientation for you automatically for now, right? Okay, so if you look over here, pin number 14 is VCC and pin number 7 is the ground. You always connect your chip before you start using it. A chip is like an appliance, right? You don't want to use your hair dryer. You can't use your hair dryer unless you connect it to the outlet. This is the same thing. You connect 14 to VCC and 7 to ground before you can use the logic chip. So here's my pin number 14. This is my top left corner. And I'm going to connect this to VCC and make it red. Now guys, when you're doing breadboarding, please color code it. It is extremely hard to troubleshoot it when you don't. And this one's going to be black. So now my chip is ready to use. So let's take a look at my diagram. So my first gate is president and vice president. All right. So let's take a look at my pinout. I'm going to choose gate number 13 and 12 for inputs to put in my president in number 13 and vice president in my number 12. And 11 is going to be the output. So I'm going to say that this switch is the president. It doesn't really matter. They're all the same. So I'm going to connect the rail that goes into the COM port all the way into pin number 13. And since on my circuit diagram it was orange, I'm going to make it orange here as well. Now this one's going to be my vice president. So I'm going to go ahead and I'm going to connect this rail over here to my pin number 12. Now my vice president was pink, so I'm going to keep this one pink as well. So far, I have connected this gate. So my next gate has, I've connected this gate over here in the middle. My bad. So my next gate is going to be president and treasurer. And I actually want to connect this gate over here on the bottom. So if you look over here, I'm going to use the number 1 and number 2. So before I do that, I kind of need to route the signal for my president all the way down. But that's not really a problem. So now I have my signal from my president going from this rail into the pin number 13 and into this column. And now I'm going to go from this column into pin number 1. So that's going to be my president. And I'm going to grab my treasurer signal over here and put this in pin number 2, and that's going to be my treasurer. So far I've connected two gates, president and treasurer, president and vice president. I have just one left, vice president and treasurer. And I want to actually, I don't feel like routing this signal all the way to the top, because you can see I have a bit of a problem over here where I'm going to stretch the wire. I don't really want to have a lot of loops. But if I route my signal for my vice president down, now I have this entire signal over here. I can connect this into that other gate over here. So let's take a look at the pins. Which pins are those? So the pins are pin number 4 and number 5. Guys, do yourselves a favor. Please keep in mind, pin number 3 is the output. Skip it for now, right? You're not connecting it yet. So I'm going to go ahead and connect my signal from my vice president into the pin number 4, making it pink. So to trace out my signal, that's purple. So to trace out my signal from my vice president is in the rail that's in the COM, is also in the rail that has pin number 12, in this rail on this side of the breadboard, and now I've connected it to the pin number 4. And of course the next one is the signal for my treasurer, and I'm going to just connect the wire from my pin number 2 to pin number 5. Now why is that going to work? Well, it doesn't really matter, you know, how I do this. I can theoretically loop it back all the way into here. But that would not look very neat. So far I have a signal. This is my treasurer switch. So this is where my the rail where my COM port is. And I'm sending it to pin number 2. And from that same rail, I'm sending it to pin number 5. So now I have all of my AND gates connected. So let's take a look. So the next ones are the OR gates. So let's go and get them. And I click on components. Once again, it's going to be the HC series, but otherwise the same. So it's going to be 74HC32. And you can see it over here, and it says quad OR gate. So I'm going to grab this one, and I'm going to place it. Well, I don't really want this one. Okay, and I'm going to place this lovely cockroach right next to my 74HC08. You will see that even in the real breadboard, this space over here is perfect for placing UIC chip. So when you look at the pinout, it looks exactly the same like the pinout for AND gates, except it has OR gates inside. And once again, pin number 14 and number 7 are my VCC and ground. I have to connect those two. So 14 goes into VCC, and 7 goes into the ground. Okay. So now I'm going to connect the gates. So first, let's take a look what am I connecting to. So over here I have PT and PV. Okay, so let's go ahead and do that. So this is my PV, and over here I have my PT. So the question is, which side am I going to use my gates on? It seems to be like it's more convenient for me right now to use the bottom side. So first I'm going to grab the PT. Well, this is just my first gate, right? And the output is pin number 3. It's in this rail over here. So I'm going to grab the signal and I'm going to put it into pin number 1. Let's make this purple or turquoise. Turquoise is a good color. Okay, so PT is now connected. So next one is PV. Now my PV is over here on the top and the output is pin number 13. So I need to route that output into the pin number 12 somehow. I can theoretically, guys, go ahead and do this. I really do not like having loops like that, because if you have too many, it's very hard to proofread. So please don't do that and route the signal instead. So I'm going to route it into this column. And let's make the color nice and blue. And from this column over here on the bottom. So far I have my output in the pin number 11. I have my output in this rail and in this rail. So now it's just a matter of connecting this rail with pin number 2. So that's my first gate. It's connected now. So let's take a look at the second one. So the second one takes the input of the first gate or gate and VT. All right, so it's pretty obvious that I'm probably going to use the gate 4, 5, and 6. So first, I'm going to take the output of my first gate, so that's pin number 3, and put it into pin number 4. All right, so that's done. And the second one is I have the output of my second gate, second AND gate. So my second AND gate on the bottom is VT. So you can see this is V, this is T, and the output is over here in pin number 6. So I'm going to go ahead and stretch it into the pin number 4, pin number 5, excuse me. Let's make this one purple. Okay. So now I have all of my OR gates connected. So next thing over here is I need to run this output into an LED. So let's go ahead and grab an LED. I don't have to look very far. It's right at the top. And I'm going to keep my color red. Now you can see that this is my short leg and this is my long leg. So I need to rotate this thing a little bit. Make sure you select it, otherwise it rotates the entire breadboard. So here now I have rotated it. So I'm going to connect the output of this gate, that's pin number 6 of my last OR gate, into the positive leg of my LED. I'm going to choose the color gray now. And the last element I've had was a resistor, a 330. So I'm going to go ahead and grab a resistor. Here it is. Now I'm going to change the value to 330. Make sure you change K ohms to ohms. And you can see that it changed its colors immediately, right? It's orange, orange, brown, obviously. And I also want to rotate this guy a little bit. So I'm going to outline it and rotate it horizontally. Right. So I'm going to connect it to the rail where the negative leg of my LED is. And now my resistor is actually supposed to be connected into the ground. So this rail has to go into the ground. All right. It's black. Okay, so let's go ahead and test this out. Does this work? So let's start the simulation. All right, so they all vote, these two, president and vice president, are voting yes, treasurer is voting no. It seems to me the light is on. That works. So now treasurer is voting yes, vice president's voting no. The light is still on. Well, let's see what happens if the president votes no. Aha, it turns off. So it looks to me like it works perfectly. All right, guys, so I know that I went rather fast in this video, but if I didn't, it would take me forever to make one. When you are following along the video and building this circuit by yourselves, stop the video every single time I place the component and take your time to actually do that and then restart it. There is really no shame in that. Just make sure you're very careful so that your circuit ends up looking like mine. After you're done this, you will be doing exactly the same thing by yourselves for your revised majority vote. It's actually pretty straightforward, but it does take a lot of time. So hopefully, guys, this video will help you out on how to do this.